Thank you very much, and thank you very much for the invitation to come here. It's a great opportunity for me. We've had a lot of information on log file data, and we've heard already a lot about self-regulated learning, and that's the perfect floor for me now, because now you are all well informed about many of the issues and the questions that I will address in my talk. So I am interested in self-regulated learning and about the traces that self-regulated learning leaves in terms of log file data. So self-regulated learning is all kind of learning in situations where you have to decide on your own what to do and how to do it. And so it's basically all about your learning goals and how you actually orient your cognition, your affect, and your behavior towards the attainment of those learning goals. The theoretical model in which I do my research is the process model of self-regulated learning by Schmitz and Wiese. And in this model, we assume that you can divide the learning process roughly into three phases, where you have the pre-action phase, in which the learner should set their own learning goals and then make some kind of a learning plan how to achieve those goals, and also activate his motivation. And then there's the action phase, which most naive people would assume is basically the learning process. It's, so to say, the phase where you're actually sitting in front of your book and actually perform your learning strategies, your cognitive learning strategies, and also your metacognitive learning strategies, and also volition comes into place in this phase. And then there's the post-action phase in which you should reflect on your success and how you performed in this learning phase, and this has feedback effects on the next pre-action phase. So you're actually supposed to think about your strategies and to adapt in the next learning situation. So that's the theoretical assumption how successful learners should actually do their learning. And we know that this kind of self-regulated learning is highly relevant for students at universities. The multiple facets of self-regulated learning, many of them are associated with academic success even more than intelligence. So it is really relevant to do research in this area. And particularly when it comes to computer-based learning environments, self-regulated learning is important because typically you don't have a teacher that tells you what to do next when you're sitting in front of the computer, but instead you are on your own and you have to set your own goals and to monitor your learning and to decide whether you are successful right now, if you understand what you're actually doing, or if you're actually not understanding it. In the field of self-regulated learning research, there has been a plea for objective measures, and we've just heard Katharina talk about eye tracking as one possible way to see to have objective measures for self-regulated learning. And my approach is to analyze log file data. And I wasn't aware of the massive expertise in this room when I prepared my slides, so I'm not going to define what log files is here, but I wanted to add that it is a non-reactive measure in the sense that it shouldn't influence people's learning that we are collecting those kind of data. So actually what we are measuring is the normal learning process and not something that was influenced by measurement, as it is the case for many questionnaires. For instance, if you ask questions about learning strategies, then people might think, oh, that sounds like a good idea, I'd try that next time. So questionnaires are not a non-reactive, but a reactive measure. But we've had already heard some problems that go along with log file analysis. So the data cleansing is very complex, and also the interpretation of log files is not as straightforward as questionnaire data might be. In the field of self-regulated learning, log file analysis is not very frequently done yet, and when it is done in what I call artificial learning environments. And with that, what I mean with that is that those learning environments were created for the purpose of research. And this has some great benefits, but also some disadvantages, and I'm going to explain that by this example. So this is one learning environment from Susanne Narcisse from the University of Dresden, I think. And she, so what you see is the learning content is in the middle, and then the learner has some different tools where you can highlight text, and or you can write down notes, or you can organize your notes into a glossary and so on. So all those tools are really beneficial for the learning processes, and I would advise anyone to include such tools in their software. But in the real world, like when you're looking at a Wikipedia page, or this is the scenario that I do my research in, you probably won't see this kind of tools. So you have the learning content, and all kind of note-taking and so forth doesn't happen on the computer. So you actually don't get log files which are linked directly to any kind of learning strategies. So in this case, you get log files like whenever a person highlights text, you get a log file. Okay, this is a person applying the cognitive strategy of highlighting text. So you know, okay, this is at least linked to the cognitive process. Whereas in such a scenario, you have no information, no direct information about the cognitive processes. But the disadvantages of those kind of artificial learning softwares is you don't actually know whether you can compare your results from this kind of research to real-world scenarios, and also the interpretation that a person uses a certain tool, and that means it uses the certain cognitive strategy as well. I think you can rely on that, because a person that doesn't use the highlighting tool might think, okay, it's just not well implemented, like it doesn't work the way I wanted it, or something like that. So problems with the implementation of the software could prevent people from using those tools, and then you would interpret the log files as a sign that this person didn't use self-regulated learning, where instead he or she just was disappointed by the software. So my goal was to analyze log files from a real-world scenario and to try and find parameters that can be used as indicators for self-regulated learning. I just want to explain the scenario briefly. It is a mathematics preparation course where people spend about 4 weeks before they actually enter university, and they do that in order to repeat again everything that they should have learned in school, so that you get more or less the same level of knowledge for all students. So at least that's the intention. And yeah, so it's some kind of the bridge between school and university. This kind of course used to be a face-to-face course, but since I don't know, like 5 or 6 years, it is an online course, and people spend their time in that course without much instruction. So this is a really huge platform with all the mathematical school knowledge in it, and you're up to yourself when you want to address that platform. Exactly. So, and what we did was analyze the learning behavior of 170 prospective students, mostly male, because afterwards they were going to study fields like engineering, so you have a mostly male population in these fields. And we recorded log files. I'm going to go into details of the measurements afterwards. So we had 4 groups that we assigned people randomly into. All of them attended the mathematics pre-course and did a pre-test and a post-test with some questionnaires and a mathematics test. And the control group C, they just attended the pre-course. Then we had the diary group, which filled in a learning diary every day, in which they stated what are my learning goals for today, how motivated am I, what kinds of learning strategies will I apply today, and so forth. So it's basically some kind of a short questionnaire that you fill in every day. Then we had the training and diary group. They had access to a web-based training on self-regulated learning, where you can learn how to improve your self-regulation, actually. And that was divided into 3 lessons. And then we had a third intervention group, which also had access to the diary and to the lectures. But additionally, they were grouped into small groups of 5 people in which they did some kind of peer feedback on their self-regulation strategies. I'll go into detail about this later on. So, yeah, and after the experiment was done, the groups D and C also got access to the training. So how can you imagine this web-based training? It is a Moodle course in which we had video instruction of how to perform self-regulated learning, and then there were also some PowerPoint instructions and people had access to a bulletin board where they could discuss several strategies. In the case of this group TDP, yeah, well, the group with the peer feedback groups, they got an extra instruction after each lesson, which referred to the content of that lesson. So after the first lesson was on goal setting and planning and so forth, so the pre-action phase actually. And after that first lesson, the peer feedback groups were asked to make their own learning plan for the whole mathematics course, and then discuss that learning plan with their peers. So they were invited to share their schedule, because in this scenario it's really not trivial to make a learning plan, because it's so much content that you actually have to think how to put all those 50 chapters into a time slot of only 4 weeks. Okay, I think most of you should be familiar with what log files look like when you download them, so I'm going to skip that. What we did was, on the one hand, what I should mention is the only information that we get is whenever a person clicks on one of the resources. So they open a new site within the platform, and that's what we get. And then they spend, I don't know how many seconds on that page, and then they open the next site, and there we get the next timestamp. So this is basically all information that we have, and inferring from this kind of information to cognitive processes is a long way. So actually, that's what we are trying to do. So what we did was just summing up how many clicks people had on the website, and in which chapters they had how many clicks, and also how long they spent in between two clicks. You have to mention in that case that we had a cutoff at 30 minutes. So in case somebody had one page open for more than 30 minutes, we assumed that he left the room and got something to eat or something like that. So you have to, this is a bit arbitrary, but you have to have some kind of cutoff, and 30 minutes seemed to be the most, how to say it, well, we're thinking about trying to adjust that and to see whether it influences our results. So now the question is how to visualize this kind of learning behavior. And I brought you two cases of people. So, and every dot is one page within the platform. So we have on the left-hand side, we have one person that went from chapter to chapter, actually in a quite linear way. So with the acceptance of one chapter over there, he or she never went back to a chapter that she visited earlier. Whereas on the other hand, we see a much more complex pattern where somebody has some kinds of loops and goes back to resources he already visited earlier. And now the question is, can we infer on self-regulated learning by analyzing such patterns? Looking at only those two cases, we thought, okay, so what kind of learning pattern is better? So we wanted to look at what the school grades of those people were. So now it's your question, what do you think? Who was better at school? Although school happened before those patterns actually were developed, but anyway, do you think you can guess who was better in school? Who is in favor for the person on the left? 2, 3, 4, 5. Okay, okay. And who thinks on the right was better? Okay, no big difference. Actually, they both did quite well in school, but the one on the left did actually a bit better. So that's interesting. When it comes to the mathematics pre-test before the course, that should be correlated with the school degrees actually. What we found was no, it isn't. Both did pretty well on the pre-test. But the interesting question is, after they showed this learning behavior, who performed better on the post-test? And now it's your question again. Who thinks the one on the left did better on the post-test? Oh, one person. And who thinks on the right performed better? You're right, at least most of you. There was a tremendous effect. Although I have to admit, this is only 2 cases, but we are like approaching a hypothesis how to analyze this kind of data. So I'm only going to look at a few possible dependent variables that we can calculate out of the log files. The first is pretty straightforward, just the simple time on task. How much time did people spend on the platform overall? And the second one is the time of day when they actually accessed the platform, because there were no constrictions on what time to visit the page. So you can actually analyze who gets up early in the morning and who doesn't. So this is an interesting question, and also you can analyze the variability of these accesses. So do people really stick to the same time every day when they open the course, or is there a lot of variability? And yeah, the third is linked to that. We have to keep in mind that the data is heavily skewed, so there's no normal distribution. And what is interesting as well is, keep in mind they had 4 weeks to access this course, and the top performer spent roughly 70 hours in the course, not every week, but overall. So the professor who runs this course actually is pretty disappointed by the students, because most of them only spend about 20 hours on the platform. That is like 5 hours every week or 1 hour per day. So this is not very much. And with this background, actually every increase in time investment is valuable. And that's what we found with our interventions, actually. So the control group without any intervention spent only like 15 or 16 hours, whereas the intervention group with all 3 interventions spent more than 20 hours on average on the website. So this is not a dramatically high effect, but still it's beneficial, we think. What is interesting is when you look at the 4 weeks of the course and how the time investment developed, we see that the difference between groups largely happens in week 3. I don't have any explanation for that so far, except that somehow the interventions were able to keep the motivation high, so to say, and then they all meet again in 4th week where motivation drops for everyone. So I don't know. It's just interesting to look at this kind of process. When it comes to the onset of learning, so at what time of the day do people start to learn? We see that there is also some kind of effect which didn't turn out significant, but still it was in the direction of our hypothesis that through the interventions people tended to start learning earlier. Although in the training actually it wasn't mentioned to, people weren't instructed to get up early, but still this was a epiphenomenon, so to say. Okay, so the next kinds of data analysis I have to explain first. So this is basically only a lot of correlations, but I didn't put it into a table because I thought it was much more instructional if I put it on a clock. So the gray area is what I would call nighttime, and the white area is what I would call daytime. And what we did was calculate how much time over the course of the 4 weeks did people spend on the website between, let's say, 9 o'clock in the morning and 10 o'clock in the morning. So every click in this time frame was calculated and summed up over the course of the 4 weeks. And then you get a number that you can correlate with outcomes of our questionnaires. So, okay, the order is not perfect. I'll explain it here first. So this is how much time they spent on the website for each hour. And it is correlated with one of our questionnaire subscales on procrastination. And what we see is that getting up early and learning in between 8 and let's say 11 in the morning is positively correlated with avoiding procrastination. Whereas learning in between 9 o'clock in the evening and 11 o'clock in the evening is negatively correlated with the avoidance of procrastination. So this is one sign that, so we can assume that procrastination is some kind of the opposite of self-regulation. And we already had findings in the literature that procrastination is actually associated with eveningness. So those who postpone their learning into the night are much more probable to be less successful self-regulators. So this might be one indicator of self-regulation when it comes to log file data. Also, procrastination seemed to be correlated with the time, with the first click every day, and also with the variability. So this number here means that the more stable, the more constant you click the website in the morning, the better your self-regulation is. So people that switch on the site at 9 o'clock on the first day and at noon on the second day and at around midnight at the third day, they are more probable to be not as good in self-regulation as those who stick to the same time of day every day. Also, we found that the overall score of our questionnaire on self-regulated learning was correlated with the total time that people spent on the website. So the correlation isn't very high, but still I think there is something behind it. So self-regulators actually have slightly higher time investment than those who are not as good in self-regulation. Going forth, there was also one subscale on time management, which showed a similar pattern actually, where we found that good time management is associated with learning in the morning and less learning in the evening. And this is the correlation with the big 5 factor of conscientiousness, which shows the similar pattern. So you might think, okay, this is only a lot of correlations, and there's alpha inflation, of course. So this is not the kind of analysis that I want to publish already, but probably if you define some time frames that are greater than only 1 hour, you get more stable results. So this was more like exploratory data analysis. And then we also correlated it with the outcome of the mathematics test, and I was overwhelmed by the effect actually, because I didn't expect it to be that high. So the total time investment in the course was associated with an improvement in mathematics test with a correlation of 0.45. So it really has a tremendous effect how much time you spend on the website actually. And in that case, it actually didn't play such a role when you spend your time on the website. At least you shouldn't learn in the nighttime. So all the gray areas were non-significant, and basically every time investment in between 8 o'clock in the morning and 9 o'clock in the evening was positive for your mathematics knowledge increase. And again, time of the first login was associated, and also the variability of this first login. Okay, so wrapping up the findings, we see that total time on task and a constant login time was positive for self-regulation, and and those factors might be used as a proxy for the measurement of self-regulated learning. The results for the subscales of our questionnaire were more or less all in the same direction, so I'm not going into detail about those. What is interesting is the question, what kinds of parameters can we derive from the data from now on? Because this is really early stage research still, I think. I think that the question whether people revisit resources that they had visited earlier already is one factor that could contribute to the measurement of self-regulated learning. We could also calculate the average duration on resources, because when your average duration on one web page is below 1 minute, you probably won't take in all information from that site. So self-regulated learners could have higher average time on each website. Also, what I would assume is that a self-regulated learner should, when entering this course, he or she should actually get an overview of the whole platform first. So what kind of log files should we expect in that case? Somebody should click into every chapter within the first 2 days or something like that. So a high amount of different resources within a short time span. so to say. So I would call that a high density of clicks into all kinds of different chapters, whereas then he or she should work his way through the chapters, and that should actually look like a pattern where you only click into one chapter at a time, or sometimes you have some kind of a thought, okay, this reminds me of another chapter, so sometimes you go back to other chapters, but more or less you stick to your chapter at that time, and then after a week maybe you repeat again everything that you've learned this week. So this kind of pattern, you could build a hypothesis or even analyze expert log files and compare those to the data that you get from other people and use that as a measure of self-regulated learning. Also, let me see. Yeah, the use of pauses is an interesting factor as well, because as we've heard, spacing, it does make a difference. So actually what you would expect from a good self-regulated learner is that he actually plans to have pauses in between, and you should be able to see that in the log files as well. And then the next step in my analysis will be the combination of log file data with the diary data, so we can actually analyze whether people spend time in exactly those chapters that they planned to visit for that particular day, or whether they got distracted and drifted away and spent time in different chapters. So this is something that we want to analyze in the near future. Yeah, exactly. There are some limitations of the data that one has to keep in mind. First of all, what I showed you were quite explorative correlations. We have to keep in mind that the sample is really specific. You might question if you can infer from this population to different groups of students. And also we have to keep in mind that not every process associated with learning actually happened in log files, because people could easily grab their school books and have some kind of learning on that resource, and we don't get any log files from that. So the log file information is limited to to the time that people actually spend online. So thank you very much.
Thank you, Henrik. Thank you so much. Fascinating time use study. Yeah, if you can call it so. With questions for Henrik?
So I very much like your analysis as a function of time, or when do they study and how that relates to learning outcomes and also to personality variables. The only thing I was wondering, I guess you have different numbers of participants in each of these time bins, and couldn't it be that some of these patterns just emerge because in some time bins, for instance studying at night, you just don't have the power to detect the same correlation as you would have during daytime when there are just more students in that particular time bin?
Good point, thank you. I don't think I checked that. That's absolutely true. Yeah, in those cases where we only have like 50 people that actually opened the website at night, the correlation can't get any significance. Good point. Thank you. Thank you.
questions, queries? Han?
So maybe a bit besides the point, but many universities, like my university, hopes to do things with MOOCs in the way they do here.
MOOCs, yeah.
And of course, the dropout is the biggest problem. So what's now your general? I know it's not directly this, but what's your general idea now to how to keep people on board?
2 points, I think. First of all, direct instruction of self-regulation strategies seems to be necessary. People seem to lack the necessary strategies coming from school, where you always have a teacher who tells you what to do next. You're not used to those kind of situations. So this is probably something that I would think that would be good. And in cases of MOOCs, you don't have the possibility to teach this in class, so you need some kind of a web-based training for that. And the second thing seems to be grouping people into smaller groups. I have a different research topic as well, where I try to find out what personalities to group together so that they actually benefit from learning together, and the effects are quite good. So having a group which is not so anonymous like a MOOC should have a good effect. And then maybe having a diagnosis beforehand whether people are actually interested in the topic or not. Because I think most people open a MOOC just because they're curious, but not because they're really motivated. And I think when calculating the dropout rates of a MOOC, you usually get up to 90% or something, but you should actually cut off all those who only opened it once and just found out that they weren't even motivated to do it. So.
I would add to that a little bit of experience. One more small thing, and that very touching on your point, of course, which is really important, is that in our experiments in MOOCs, we don't realize, particularly in higher education, how important the teacher is in emphasizing to the students the importance of the material or the relevance of the material. Oftentimes MOOCs don't take the time. They put a lot of energy in structuring the material well, and make it easy to access and plotting out a pathway to get through it, but they don't spend time emphasizing the importance or value of that work to students. So students miss out on that, and that's something they often get from being in a social context or getting feedback from teachers. Good teachers spend a lot of time talking about that. That's another way to enhance MOOC environments. Yeah.
I think personal relations between students and the lecturer on the one hand, and also between students among each other are really a key to addressing this.
I think I'd like to ask a question too. So I very much like the idea of the different aggregate measures that you're pulling out of the data set, but I was curious about this loop. You mentioned it briefly. So you have a record of which units the students have read, but do you also have some kind of measure of they perform some quiz or some performance of each of those sections? I don't know if you have that.
We have information about that. So the resources fall into different categories. There were like self-tests, and then there were examples, and then there were sites which showed typical errors and so forth. And we're going to explore that as well. So whether self-regulated learners use more of the self-testing sites, for instance. Yeah.
Okay, thank you, Henrik.
Thank you very much.